Hi there, welcome to Nauctis on YouTube.
The United States Air Force operates various sophisticated and modern aircraft. To operate them efficiently and in accordance with established procedures, professional pilots are required. But have you ever wondered how these pilots are trained to handle aircraft effectively? The answer is quite simple. They undergo specialized training before they are officially allowed to operate aircraft. However, the training they must undergo is not easy, given that being a pilot is a challenging and demanding profession. Before enrolling in and undergoing training, prospective pilots must meet specific requirements, particularly concerning their physical health. Some of these requirements include meeting weight limits as specified in the qualifications, having no history of diseases after the age of 12, such as asthma, fever, and allergies, and possessing normal color vision with near vision acuity of 20/30 and distance vision acuity not worse than 20/70 in each eye. In addition to physical requirements, prospective pilots must start their pilot training between the ages of 18 and 33 and be U.S. citizens. They should hold at least a bachelor's degree in any field with a minimum GPA of 2.5. Furthermore, positions for pilots and aircrew have varying height specifications, which are adjusted according to the aircraft. Applicants who are significantly taller or shorter than the average may require special examinations to ensure they can perform operational tasks safely. For those who meet the qualifications, they are eligible to attend an academy training program that can take up to 4 years. Following that, they must undergo pilot training for an additional year or more. Prospective pilots undergo physical and mental training as well as extensive exercises until they are deemed qualified to join operational squadrons. Before piloting actual aircraft, trainee pilots practice using special flight simulator equipment, typically computer-based. These simulators are equipped with advanced technology to provide a real-life flying experience. Training with simulators is considered cost-effective for the United States Air Force, in addition to being more efficient and safe for trainee pilots, especially for practicing high-altitude maneuvers. One common simulator used for training and introducing basic aircraft concepts for trainee pilots is the F-35 Lightning II cockpit demonstrator. Generally, pilots can complete nearly 50% of their initial training virtually. This training includes all air-to-air, air-to-ground missions, and even combat scenarios. Once they pass their virtual training, trainee pilots move on to training with actual fighter aircraft. Despite fighter aircraft being equipped with advanced features and technology, the pilot's skills are crucial, especially during high-speed aerial combat maneuvers. During actual flight testing, trainee pilots will be trained in every aspect. They will be required to fly at higher speeds than their adversaries. However, one important lesson for trainee pilots is to understand their aircraft. Some of the aircraft characteristics trainee pilots must master include the rate of roll, climb rate, maneuverability, and thrust-to-weight ratio. On the other hand, they must also be aware of the positions of other aircraft or even enemies while flying. During high-performance aerial maneuvers, pilots often experience heavy mechanical loading. Pilots often complain of neck pain and injuries due to high-speed maneuver exercises. However, these maneuvers help improve students' balance, strength, and flexibility. Despite the physical strain, maneuver training enhances pilot abilities. Once trainee pilots can perform maneuvers smoothly and effectively, they will be capable of handling the critical 9Gs effect during fighter jet operations. The 9Gs effect is quite extreme as it can move blood from the head to the feet rapidly during positive G loads and from the feet to the head during negative G loads. Pilots experience negative G loads during steep climbs or high-speed turns. At that moment, blood flow induced from the head to the lower body can reduce blood supply to the brain. To avoid this, a pilot's body must quickly respond to increased blood supply to the upper body. The eyes are the first organs to respond to low blood flow. However, if this does not happen, there is a high chance that the pilot may lose consciousness. To ensure trainee pilots can handle 9G's maneuvers smoothly and without hindrance, they are also provided with experience through training using a device called the human centrifuge. Trainee pilots are placed in a room connected to a rotating arm. The device is controlled by personnel at the Centrifugal Force Control Center. These personnel also monitor physiological data on G-force settings and communicate with each pilot being tested. Despite experienced pilots being considered professionals in their field, they often struggle with spatial disorientation. To address this issue, pilots are trained with a large device called the Kraken. This device combines aerospace physiology with advanced technology. Pilots typically train with the Kraken device owned by the Navy Medical Research Unit located at Wright-Patterson Air Force Base in Dayton, Ohio. Kraken offers 6 degrees of freedom that can fully replicate all possible flight maneuver scenarios in real-world flight scenarios. The device also provides pilots with illusions that can evaluate their actions. When trainee pilots are tested in the Kraken, the teams are there to examine a collection of hundreds of sensors taken from the trainee pilots. This is done to expand their understanding of spatial disorientation. In addition to Kraken and the human centrifuge, novice pilots are also required to undergo altitude chamber training. Unlike previous devices that could only accommodate one trainee pilot, the altitude chamber is larger and specifically designed to accommodate multiple pilots simultaneously. The air pressure inside the chamber can be reduced to create a low oxygen altitude condition. Trainee pilots are trained to deprive themselves of oxygen to experience hypoxia-like conditions. This allows pilots to identify symptoms and understand how their bodies react to hypoxic conditions. Pilots can apply this technique when performing high-speed maneuvers in the air. When flying fighter jets, pilots sometimes occur unexpected problems with their aircraft, ranging from malfunctioning engines to the worst-case scenario of fire on board. Therefore, pilots must be able to eject themselves from the aircraft in such situations. It should be noted that every pilot seat in a fighter jet is equipped with an ejections device. In the event of an unwanted incident like a fire, the pilot can activate the ejection seat. When activated, the top of the aircraft automatically opens and the pilot is ejected from the aircraft. The pilot will also parachute to land safely. However, the ejection process requires extra training. If not trained properly, the ejection force can cause fatal damage to the spinal cord and other vital organs. Therefore, pilots must undergo another crucial training called the lateral drift trainer. The lateral drift trainer aims to master parachute skills for every trainee pilot. In addition to parachute jumping training, trainee pilots are required to undergo water survival training. This is to provide students with an understanding of what to do if their aircraft crashes into the water. By doing so, they hope to be able to survive in the water until rescue arrives. Water training can consist of several parts that cover all possible scenarios in the water. One part of this training is that pilots will be towed by a jet ski to create the effect of being dragged by their open parachute. With all the training they have undergone, from high-speed maneuvers to dealing with hypoxia conditions and extreme weather training, trainee pilots are expected to operate their fighter aircraft smoothly and professionally. If not done correctly, there is a high risk of fatal accidents and their lives may be in danger. However, as time goes by, modern technology in the form of artificial intelligence, or AI, has assisted various professions, including operating fighter aircraft. Their artificial intelligence program on fighter aircraft operates under the Air Combat Evolution or ACE, which has evolved from controlling dogfight simulations on computer screens for F-16s to controlling them in real flight. The ACE team and several algorithm developers uploaded their AI software into the F-16 variant called the 𝗤𝗃𝗃 𝗵𝗃 in December 2022. The aircraft was specially modified for this purpose and served as a testbed for simulator flights at the USAF Test Pilot School and for several flights over several days. The results of these tests showed that AI technology can fully control fighter jets and provide valuable real-time flight data. The U.S. Air Force has tested two programs. The first program is developed from the Autonomous Air Combat Operations or 𝗖𝗍𝑐𝗷𝗹𝗯 Research Laboratory. This program involves one-on-one air combat simulations in 𝗫𝗏 aircraft facing challenging adversaries. Meanwhile, the second program focuses on testing aerial combat maneuvers in a visual range for 𝗫𝗏 against adversaries. Once the AI algorithms and technology are integrated into 𝗫𝗏, the aircraft successfully performed predefined flight maneuvers. This indicates that the algorithm system has taken complete control of the aircraft successfully. In these two different programs, the military only needed to run the tests for a few hours. AI technology in fighter aircraft continues to advance, but further efforts are needed to develop advanced technology. Even though AI technology has helped with maneuvers and dogfighting, the role of fighter pilots is still highly essential in operating fighter aircraft. Of course, these pilots must also be equipped with knowledge about AI technology in their aircraft.